Next example, I've got a perfect example here, is I want to find the measure of angle A. Look at angle A. Here's angle A. What do I know? I know the adjacent side, which is 3, and I know the hypotenuse is 15. Well, adjacent hypotenuse is cosine. So I'm going to say, oh, the cosine of angle A is going to be my adjacent side divided by my hypotenuse. In this case, I'm going to say, oh, the cosine of angle A, my adjacent is 3, my hypotenuse is 15. Now, to find the measure of angle A, I'm going to do the inverse. So the measure of angle A then is going to be my inverse cosine of 3 over 15. Well, I'm going to say that's 1 over 5. I'm just going to reduce it. No, you don't have to reduce it. I'm just going to reduce it. We can do the same thing. So the measure of angle A to the nearest tenth, I go to my calculator, and I'm going to do the inverse cosine of 1/5. You could have write 0.2 in there, couldn't you? And you get 78.46. And we want it rounded to the nearest tenth, so I'm going to say 78.5 degrees. There you have it. Now, when you solve a triangle, if the directions say solve the triangle, that means I want to find everything that's missing. I want to know the angles. I want to know the sides. You need to know 2 things to solve a triangle. It's got to be a right triangle first. We can't do this if it's not a right triangle. That's a different rule that you'll learn in Algebra 2. But to solve a right triangle, what we're going to do is we're going to find everything that's missing. You can use proportions. You could use special right triangles, Pythagorean theorem, and our right triangle trig we just learned. Do the easiest that's for you. That's what I'm going to tell you to do. Now, if we notice here on this triangle, I've got 2 sides. To me, the easiest way to find the missing side is Pythagorean theorem. So let's do that first. We're going to say c squared equals a squared plus b squared. On this problem, we know the hypotenuse is 9. So 9 squared equals 6 squared plus, I'll go rs squared, so just to remind me, myself, what I'm solving for. And we're going to round everything to the nearest tenth when we do this. So then we get 9 squared is 81 equals 36 plus rs squared. And then to solve for rs, we're just going to do a little bit of algebra. We're going to minus 36 for both sides. And I like to write my variable on the left side. I don't know about you. So rs squared, if I take 81 minus 36, I'm going to get 45. And then I take the square root of both sides, and we're going to get the square root of 45, and that's 6.7. Now I need to find either angle R or angle T next. I think I'm going to use angle R. So angle R, right here in the corner. And I could use 6.7, but then I'm going to get some rounding error. So I'm going to use the 2 numbers I know. So 6 and 9. And notice that's opposite and hypotenuse. So I'm going to go back here. The sine of angle R is the opposite divided by the hypotenuse. So the sine of angle R is 6 over 9. So to find the measure of angle R, I'm going to do the inverse sine of 6 over 9. And I'll just divide those by 3. And I'll get 2 over 3, won't I? 6 over 9 is the same ratio as 2 over 3. I don't want to put the decimal in here because that's repeating, isn't it? So to find the measure of angle R, I'm just going to use my calculator. I'm going to say, okay, inverse sine of 2/3. So inverse sine 2/3. 41.8 degrees. No, you don't have to use trig to find angle T, because no, we got a right triangle. We know they're complementary. So the measure of angle T is to be 90 minus 41.8. If you can't do that in your head, just go 90 minus 41.8. And I get 48.2. So the measure of angle T is 48.2. Now we've solved this triangle because we found the missing side and both angles. And that's what we were tasked to do in this question.